Okay, lesson number 3 of this unit. We'll be looking at surface area again, but instead of right prisms, we'll be looking at right cylinders. Notice that the radius of the circular base is going to be the radius of the cylinder. For height, we have to be perpendicular. And it's going to be straight vertically up and down, not at some weird slant. So the only two numbers we really have to play with is the radius and the height. So each base is a circle. And then that curved surface, if you think of a can of soup and think about where the label would cover the can of soup, that's our lateral area. Now, if you think about the prism, we all said, hey, it's perimeter times height. Well, same thing with the cylinder. It's perimeter times height. But with the circle, we don't say perimeter, we say circumference. So 2 times pi times r is the circumference of the circle. But that's really still just perimeter times height. And then for the total surface area, we have to add the two bases to the lateral area. So again, for the lateral area, 2 times pi times r times h. Surface area, you've got two bases, and you've got the lateral area. Bases are just circles, so that's pi r squared. The lateral area is actually just a rectangle, so you just got to do length times width. Length, 2 times pi times r, because that's how far it is to wrap around that circle. Height, h, would be the height of the cylinder. Right? So length times width, 2 pi r times h, gets you 2 pi r h. So probably a little simpler than the prisms because you've only got 3 pieces, a base on top, a base on the bottom, and then the lateral area is literally just one piece. So if you want to just remember 2 times the base plus the lateral area, you can always work it out. If you're more of a formula person, you say, no, I can remember 2 pi r squared plus 2 pi r h. And I'm going to show you a variety of ways of calculating the surface area because everybody works a little bit differently. So for this example, I'm just going to do the straightforward lateral area plus the surface. I'm sorry, plus the bases. But got tongue-tied. The lateral area plus the bases. So I know the lateral area is 2 times pi times r times h. And I will just figure that out as my first step. Looks like the radius r is 4. The height h is 8. So I plug those in. 4 times 8 is 32. But I can remember there's a 2 out in front also, so 2 times 32 is 64. Lateral area, 64 pi. Now I'll take a look at the base. For a circle, of course, it's got to be pi r squared. So the area of the base will be pi r squared. Of course, the radius is 4. So 4 times 4 is 16. There's my base. Now I can put it all together. The surface area is going to be 2 times the base plus the lateral area. So 2 times the base Well, 2 times 16 is 32. Then I got to add the lateral area. 32 plus 64 is 96. And of course I need a label. If we're working in meters, the surface area will be square meters. That's an exact answer. If the directions request a decimal, I can always grab a calculator and go 396 times pi. I can use my pi button on my calculator if I want to be pretty precise. I can do 3.14 if I'm not quite so concerned about being quite so precise. And again, instead of putting meter squared, I could put square meters, right? SQM, however you want to put the label on there. I'm going to show you a slightly different method because some of us like to just memorize formula. If you'd rather just memorize a formula, you say, hey, I'm going to remember that's 2 pi r squared plus 2 pi rh. Radius, of course, is 10. So anytime I see r, I've got to substitute 10. Height is 18, so anytime I see h, I've got to substitute 18. 10 times 10 is 100. 10 times 18 is 180. 2 times 100 is 200. 2 times 180 is 360. So if I've got 200 pi plus 360 pi, makes 560 pi. If I want, I can write it out longhand, square inches. Or if I want to really shrink it up, I can put inches squared. Right? So if I'm asked for a decimal, I can do 560 times pi. Round off to the number of decimal places I requested. Here I just happen to round off for 2. Now we're going to come back and take a peek at this exact same example in just a moment. But first we're going to manipulate that equation. All right, this is like our public service announcement. Right cylinders, we can figure out the lateral area, piece of cake. An oblique cylinder, we're not going to touch it. That is very complicated to figure out the lateral area. And now let's manipulate formula. Notice I tried to put a really fancy looking plural form. Most of us would say formulas instead of formulae. Okay, so let's take a look at the formula we used in that previous example. I rewrote r squared as r times r. And the reason why I did that is I wanted to identify a common factor. 2 pi r is a common factor in those terms. So I factor that out, I get 2 pi r times the quantity r plus h. Okay, so as promised, I'm going back to this example that we've just done. And I'll say, no, I'd rather use this formula. I'd rather use 2 times pi times r times the quantity r plus h. Better get the exact same answer because it's the exact same prism. Every time I see r, I substitute 10. Every time I see h, I substitute 18. 10 plus 18, of course, is 28. 28 times 10, well, that's 280. So I've got 2 times pi times 280, so I better do 2 times 280. Hey, 560 pi square inches. Of course, it's got to be the exact same answer. And notice I showed all the possible ways, well, maybe not all, but showed 3 ways of designating that it's square inches, right? I can write out words, I can abbreviate each word, or I can even use a superscript of 2 for squared. I want to do one last example because I want to show you how I often do it. Right, everyone's brain works a little bit differently. I'd like to say, hey, lateral area. I know it's going to be 2 times pi times r times h. So I got to do 2 times 2 times 7. That'll give me a 28 with my pi, right? 28 pi. Now, of course, I'm going to look at a base, and I'm going to claim the base is pi r squared. And of course, 2 times 2 gives me a 4. Now, here's the little twist that I like to do. I like to do base plus lateral area, right? Because with a cylinder, you really only have 3 pieces. All right, so instead of 2 times the base plus the lateral area, I often just do base plus lateral area. It just helps me remember that with the cylinder, I got all 3 pieces. Right? That's a nice visual clue. It's like, hey, I use both bases and I use the lateral area. It just kind of cements in my brain a little bit more what I'm doing. Don't necessarily do this with a prism, because with a prism, when you put out the net, and if you think about a rectangular prism, you've got 6 faces grand total. And I don't always feel like trying to add up each of the 6 faces. But with the cylinder, I say, hey, piece of cake. I like to do base plus lateral area. Of course, one of our superheroes that was picked up neither by Marvel nor DC, it's Batlama. The worksheet will work with surface area of cylinders. The IXL will be more practice with nets of 3-dimensional figures.